Case number 4. We've already looked at 3 cases where the derivative does not exist. We know that the derivative does not exist when the function has a corner, a cusp, or a vertical tangent line. But what about this situation right here? F of x is a piecewise defined function. The function is equal to -1 if x is less than 0. The function is equal to 1 if x is greater than or equal to 0. Does f prime of 0 exist? Okay. So to graph a piecewise function on the calculator, you have to use your test command. I'm not going to really worry about that right now. This right here is the piecewise defined function that I just described. So if I take a look at the graph, so I'm going to do zoom, option 4. Okay, we see -1 when x is negative and +1 when x is positive. Okay, that's our graph. And the question is, does the derivative exist right there when x is equal to 0? Right? And the answer is, well, no, because we know that the derivative is the limit of the slopes. But the slopes, if we're looking at 0, we're up here, but there's nothing connecting to it from the left side. The left side moves down to this spot. So we actually have no way to create a tangent line. We can't turn this big gap right here. If we zoom in enough, we cannot turn it into a line. Right? And that was the idea with this, being locally linear. There is no line for us to create. There's no curve for us to turn into a line at x equals 0. Right? So this is our final situation, and that is when there is a discontinuity. Okay. So if we have a discontinuity, then the derivative will not exist at that point. Okay. So think about it. When do we have discontinuities? Well, if we divide by 0, that was situations where we had a discontinuity, or also in a situation with a piecewise defined function, if the limit from the left, in other words, in this case, the limit from the left of the function as x equals to 0 is -1, but the limit from the right is 1, so the limit did not exist. So another situation where we could have discontinuities is when we have a piecewise defined function. All right, so those are situations to look out for. What would cause our function to have discontinuity, and whatever value of x causes our function to have a discontinuity, that would be a situation where the derivative does not exist. So those are our big 4: corners, cusps, vertical tangent lines, and discontinuities.